Welcome to episode 12 of Box Turtle Bites. I'm Jason. He's TJ. TJ, what are we doing tonight?
We're going to do some exploration around Rust and what it's
Rust.
about. I'm sure everybody's heard.
Rust is super fast. It's super efficient. It's like the panacea for all things
everything.
software. So, yep. So we're gonna spend a little bit of time digging into it. So this is gonna be a lot of me talking and kind of showing stuff because I've spent a little bit of time over the last several weeks digging into a little bit. I am no expert, like straight up, not an expert at Rust. So I'm gonna say some things that are gonna be like probably flat out wrong, or at least be like, yeah, I don't really know about this. It's just I'll gloss over stuff, but I'm gonna try to at least set us down a decent path. So we'll see how it goes.
I think a good intro is always good. I mean, especially with all the buzz around it. And don't get me started on how many JavaScript frameworks and builders and and everything is being written in Rust. Although TypeScript went with Go,
which is actually a really interesting move. And so I don't know Go, although I think when I was reading about the decision for TypeScript to do that, a lot of it was around the similarities of Go to JavaScript, TypeScript, so that it was less of a mental shift, which frankly, probably not the worst idea. So I'm gonna share my screen here and we'll kind of dig into this. I know when I told you I was digging into this several weeks ago, after a couple days, I'm like, it's not that bad. Once you start getting into it, it's you start running into some of the edges a little bit harder. So we'll get into it. But there are some things about it that aren't too bad. But we'll talk about it.
Cool.
So what I have here is I actually created this project, and this is one of the things that really always bothers me is like you'll go see examples, and so just a little bit of context here. This is going to be running a service. Just call it example service. It's running Lambda functions. One of the big things where Rust started hitting for me, where I started hearing a lot about it, was like, do your Rust and your Lambdas in Rust, the cold start times are exceptionally low, and they are. You get like 10 millisecond, 12 millisecond cold starts from a raw Rust function. Like super awesome.
And why is it?
Because it doesn't have a runtime, because it doesn't have all the overhead. So, and we'll get into some of that because that actually plays into some things here once you get past doing the most basic things in Rust and why it's not quite as great as maybe you originally were led to believe it was going to be. But anyway, but it still is. It is so fast and efficient. But one of the things that always bothered me is like I go out there and look at examples and they'll be like, here's how to create a Lambda function in Rust and deploy it with CDK and yada, yada. And it's always one Lambda function. And I'm like, okay, but like how many times have you deployed a service and had one Lambda function in it? Like not very often. So I spent a little bit of time trying to get this thing up into something a little bit more robust. So we'll talk through that a little bit. So what ends up being interesting is Cargo is something you'll see all over the place. Cargo is kind of like their packaging system. They're called Cargo. You'll see Cargo Lambda, which is an extension that's used for running Lambdas in it. But Cargo is their thing, and it's got like, so if you think of this sort of like your package JSON
I mean, it's even got a lock, right?
Exactly, it has a lock. So what you're looking at here, though, is this is the workspace file. So because I did this as a project, as multiple applications, so to speak, in one, this file is kind of defining where all those things are. And then the lock file actually is one lock file for the whole thing. But what you'll end up seeing is when we get down into individual things, there's a cargo file here where the dependencies actually exist and where like the name of the package and versioning happen in here. And then all the code for each of those things. So
almost similar to like a tsconfig kind of. It's like tsconfig combined with npm.
I would say in some respects it ends up being similar to, not quite the same as like oh man, what the heck is that stinking packaging thing that we just removed?
Next.js.
Next.js, or not Next. I don't know. I don't remember, but where you can have where it rolls up the dependencies into one place. Because ultimately,
NX.
NX, yeah. ultimately, like this package is added here, but it gets locked all the way up here.
Yep.
So you add the packages in different places. TOML
and
files,
they're
by
called
the way.
workspaces, right?
Yeah, this is a workspace at the top level when you want multiples, and if you inside each one is just a package. So package is what you most often do. It's when you see examples, they're all going to be packages.
Lambda 2?
Lambda 2, yep. And, when we talk about that, that'll be kind of interesting. You'll see like every Lambda function is its own little program.
Yep.
I hate TOML files, by the way. The thing, like they're great when they're like this, and then the moment you get into where it doesn't do something, what do? We do JSON in the middle of the TOML file. I'm like, so just make it JSON. Like, come on, like let's not play around, but whatever. So the biggest thing with Rust is everything is either a library or a program. So when you want to share things, like you probably can do some file reference things if you really wanted to, but really you share it as a library. So this file here, this is just like a typical like models, right? So there's a user object here.
Yep.
And I'm sharing that out via a library so that it can be consumed anywhere else in any of my other packages. Ultimately, I could publish this someplace and put it in like kind of like a package where I could download it places, but
through Cargo or
yeah, exactly. Yep. They've got a public one. You can share them another way too, and I actually haven't really messed
that much. Does GitHub have that?
Not sure. It's a good
question. Let me look while you keep going.
Yeah. So inside this, one thing you'll see here, you'll see these kind of declaration things on top of things. This is very similar to like if you use .NET and you remember like JSON, Newtonsoft, was that what it was? Did all the serialization stuff in .NET before they kind of replaced it. This SERDI, I can't remember how to pronounce it, but it's the serialized, deserialized thing is kind of the de facto thing to do. And so these basically are telling it, hey, you can deserialize this, serialize it. I've got something here to say change it to camel case, because in Rust the standard is snake case, which I'm not a fan of, but whatever. When in Rome, so to speak. So this is just a little library that is my models. Well, I broke this up into kind of how I would typically do it. So I've got a data layer. It knows how to talk to, in this case, knows how to talk to Dynamo. I've got a business layer that knows how to apply any business logic to things. And then I have handlers. And so I put a bunch of them in here. Most of these aren't really doing anything, but I wanted them to all actually build something and actually like be able to be deployed so I could see how does this work, like if I have a whole bunch of stuff. And so we'll start with the simple one because this is just a simple Lambda function that takes a payload and returns something. It's not designed, it's not hooked up to like an API gateway or anything. But you'll notice in its dependencies, I do have dependencies on these 3 libraries that I've included in here, and then a whole bunch of other stuff. That
one of the questions that I have for you. So like when you use those Node.js functions, it automatically strips out like the AWS SDKs, right? Because it's built into the Lambda runtime.
Yep.
Does it do something similar with?
I don't think so, and the reason why is because it's very different the way it does it. So if you think about like Node or Python, those languages are running sort of, there's a runtime, right? And so it's not actually running your code. It's not really compiling it. You're just it's interpreting it, right? And so it's got a runtime that runs it. When you compile something for Rust, it's actually compiling it. You have to actually compile it to whatever framework, whatever system you're running on, whether it's an ARM system, a 64, ARM 64, x86, whatever. So it actually has to be really tuned down to it, and you compile it down. I think you could probably get what you're asking for as far as like a Docker container where you would build it, where you would have libraries pre-built, right? So and as a matter of fact, when you do a build, it will cache similar to what you'd see in a lot of things. It will cache, it's already built this, it's not going to rebuild it.
Yep.
So a lot of times I think that's what you'll do from an optimization, from a deployment perspective, is to keep that from happening. But once it gets on the machine, it's just literally the binary. That's it.
Right. And that's where the speed is, right? Because you aren't accessing the runtime and doing build, just-in-time compilation.
Exactly. No, none of the just-in-time compilation, none of the overhead of garbage collection or any of those things. So yeah, that's where you get a lot of your advantages. So anyway, this has got references to, AWS SDK and all that stuff. What you'll notice is pretty much there's two types of things in Rust. There's a library and there's a executable. You can have both in the same thing. You'll see that a lot with like little command line utility type things where they'll have a library that is like exposes all their stuff via code, but then they'll have a main that, like CLI type thing. But the main is where things are going to come in and enter and actually do the work. And so this is again, ultimately calling a Lambda function or being called by a Lambda function. So you'll see here, this is just hooking up their logging stuff. Nothing really special there. This is kind of an interesting one here. The shared config, effectively what it's doing is loading all the stuff from the environment variables.
Interesting. So
it's getting like your region, your credentials, where you would pull them off of like inline stuff. The interesting thing about this
of Express setup.
Yeah, it is, and you'll see that actually even more when we get into the API gateway one. It looks a lot like Express. What's interesting here is this bit of code. So this has an await on it, and their await is a little weird about it. They did it for a specific reason, but the await's at the end. But it actually has to go do like file access, like trying to find stuff on the file system and all that stuff and reading from different places. This actually can take like 100 milliseconds. It's crazy.
And that's probably why they have it up there, right? Because that's
exactly why it's there.
Once it's loaded
and not only that,
warm and hot starts.
And not only that, this code here, before we are inside this run here, this code here actually runs during the init phase.
That's great.
So it actually happens before the actual code actually hits it. So if you were to, for example, they don't really have this, but if you had like the ability to what the snap start type thing where it would run it, this stuff would already be there. So anything you want to cache between sessions, anything like that, you would do here, right? And so you would have kind of that state.
That's only going to run on the cold start, basically.
Only on cold start, correct.
So anything warm, like you aren't going to pay that init cost, and so like, you can really like offload a lot of that heavy lifting.
Yeah, anything you have that doesn't need to be done again, do it here. Absolutely. There's some stuff happening here. We'll get into a little bit later, but like where the way memory works in Rust is really where all the complexity comes from. 100% of the complexity in Rust is all about memory. It's also part of what makes it so safe, but it can be a beast to understand. So we'll get into a little bit like why this is cloned and this whole concept of moving and stuff like that in a little bit. But ultimately, this is kind of weird. This is an inline function. So this would be like open, close paren, big arrow if you're in either .NET or JavaScript. It's just two pipes with the parameters between it, and then open, close brackets. Weird to look at, but that's what it is. So ultimately, we're going to call this function handler, and that is going to be here. And again, it just gets an event. This is a Lambda event, happens to be with my user object inside of it.
And those types are produced by AWS, right?
Yep, these ones are the Lambda event is produced by AWS. This one, of course, is my type. Yep. And then this is the shared config that I'm passing that config in here as a parameter. So I'm going to create a new DynamoDB client, create that user DB data stuff that's down or that's here in my data section. I'm going to create the business thing here, passing the database to it. I tried to, by the way, I was really trying to make Jeff happy and do some injection stuff. Injection is challenging. The memory stuff makes it pretty tough. I just said, you know what? I'm not going to deal with that right now. I just want to understand this. So,
yeah, most of the examples actually don't.
They don't.
They do follow a very similar design to how they manage their dependencies and how you import them and stuff like that. And so, like, I do question whether or not, like, I got dependency injection when we were running in containers, and like, and not like the Docker container. I'm talking the real containers.
Right. Yeah. There are some testing advantages around it, right? Like it makes it really easy to write tests when you can scope down things really well. And like, I get that. And that's great. I think the model to achieve that, this is more of a functional programming language.
Yep.
And so you almost need to pass things as functions and it becomes a little different. But what becomes really weird with Rust is you can create interfaces effectively. They call them traits. You can create these interfaces, but because Rust needs to know at compile time where the memory of things are, it becomes really challenging to create some object of unknown size and pass it around.
Yep.
Because it wants to understand things, and you have to end up having to do these boxing things, and we'll talk a little bit about how await isn't even really handled very well, and so there's some limitations on asynchronous stuff there that makes it really challenging. So I just completely avoided that and went the simple route. But ultimately, what you see happening here is off the payload. The payload is my user object. I'm going to call save, passing in by reference. That little ampersand means by reference. Awaiting. This question mark is all about dealing with, you have to handle everything. Things come back like this actually returns a result, which is always either okay or error. If you don't handle it, it just basically is going to, this question mark is just saying, yeah, if I don't get it back, take that error and pass it along to the next guy.
Because it'll sig kill it, right? Like
it will. If you don't handle it right, it'll basically kill the entire app. Which
it's not JavaScript, fellas. You can't just throw things everywhere.
Yep. If you're running Lambda, like it's not the worst thing in the world, right? Because although you lose your cold start stuff, and that's not great. And there are some implications of that, so don't do that. But it wouldn't be the worst thing. But ultimately, you really shouldn't. Even this question mark here isn't the best thing to do. What you'll see a lot is you'll see a lot of like unwrap or default or else or something like that. And what that does is say, grab this thing, take the okay result, and if I don't have an okay result, give me this other value instead.
Yep. Yeah. And try catch basically.
It's similar to try catch. There's enums are a big thing here, and enums are kind of the way they do it. And it's kind of weird, but okay is actually part of an enum. It's part of the result enum.
Cool.
So we're just returning a message. Again, not a whole lot happening to this here. Kind of shows the simple how this works. The main thing here is that there's a main function, and then I'm calling another function that's doing all the work. I use CDK here. So the CDK is going to look very similar to what we did before, but I'm going to show you this.
It's not in Rust? I'm kidding.
So that's actually kind of interesting. So I actually very much prefer to like have all my language the same, right? Like to me, that's a big reason why I like TypeScript, because I can use it on the front end, the back end. I can use it for CDK. And it gets me away from this like mental context switching that ends up having to happen whenever I switch. I would love it to be in Rust because I hate having to switch between these. And I also like, how I am with this stuff. Like I want my CDK construct to be right next to the code that it's doing it, and I can't really do that now. Yeah, I can't do that. So I tried to like model it to where the folder structure was the same, but it's not the same.
Yep.
But anyway, it ends up not being too bad. So here's a couple things that are interesting. There's a Rust function. It's Cargo Lambda CDK, so it's using their Cargo Lambda stuff. What's interesting here is the function name is really important. The binary name and the manifest path are the two important things here. The manifest path for this case, because we're using workspace, is just the root.
Really?
So okay. Yeah. So I don't have to go down and dig into whatever things there are down here. That I don't care about that. I just need to get back to root. So however deep I am, I just dot myself back to there.
Yep.
And then it's going to use this binary name. And that binary name has to be unique across your everything. And that's going to come from your Cargo Lambda file. And it's just this.
Oh, that's cool.
So where that really comes in is you do have to uniquely name things. So like if I wanted to have, a DynamoDB stream that was based off of, users, I have to name this one. That one's just DynamoDB. Oh, I think I did SQS was the one where I did this, where I was like, okay, I'm going to have a user one, SQS user events. And then I had another one for EventBridge, and I called that one EventBridge user events. And so I had to uniquely name them down in here. Kind of the drawback, but not really that big of a drawback.
It's definitely a drawback, but it also isn't too bad because like it being separated, like, you know, in our TypeScript ones, it's easily relatable back to the handler. Yep. In this case, that's kind of that connection. So like when I need to control find what the heck is this function using, like at least I have a crumb.
Exactly. I've got something that I can go back and find it across it. So it becomes a little easier. So that's not too bad. And again, there's not a whole lot happening here. I'm passing in a table name. I'm granting it read right on that table so that I can do whatever I need to do.
Talk about the architecture. Like I know you're like most people are going to use ARM64. Like how does that play into the TOML and all the build process type stuff?
Interestingly, not a lot. It will play into when this CDK code runs, it's ultimately going to run cargo build.
Oh, okay. So
build it.
This is is it L2 construct?
L2 construct, yeah.
That's great.
Yeah, exactly. And so ultimately it's going to create these target stuff. You'll see this AR64 unknown out Linux GNU. That's what this is. If I were to change it to something else, you'd see a different target down here, like this X64 one.
Cool.
So it really does that all that for you. It ends up being really simple.
The L2 constructs, they really save time.
They do.
If you've ever tried to do that, with an L1 construct, that's tough.
Yeah. So if you were to try to do this with an L1 construct, you would have to. It would just be a raw lambda function, which would take a binary, some code, right? And so then you would have to do the build yourself and then find the right binary and put the right binary into it. This does it all for you. So it's actually pretty nice.
Pretty nice.
Yep. All right. So here's where things are really interesting. I did some basics, Event Bridge stuff in here, and we can.
I want to see the API gateway.
Yeah, that's the fun one. Yep. So this one's interesting. Okay, before we get, I'm going to show you some stuff in here, and we'll talk a little bit specifically about Tokyo, because that's kind of the big one. And Axiom is probably the closest, similar to Express. It's one of the common servers that you can use that kind of handle, routing.
Tokyo's the JSON.
No, that's SIRD is the JSON serialization stuff. Tokyo, I'll show you here a little bit here. Tokyo, you'll see this on top of a lot of software. Tokyo main. And ultimately what this is Tokyo is a async runner.
Oh, okay. So that's how they're trying to get the await.
That's how they're getting the await, yeah. So you can do await stuff yourself. You can handle your own threads and all that stuff. And as a matter of fact, if you go through the examples, if you go the examples on Rust Lang stuff in the book, they'll have some stuff in here about async. Don't remember exactly where it is. Probably down in here. And they do some stuff without a Tokyo library. They'll show you how to do some of that stuff, but the Tokyo is kind of the de facto standard. It's what everybody uses.
Yeah, the normal use case isn't going to want to go down to the layer that is available in the language itself.
What's interesting is that unlike .NET, Node, Python, any of these other things, it doesn't have a runtime.
Oh, interesting.
So because it doesn't have a runtime, it can't just do this stuff for you. So it needs something to manage all the running of the state of keeping track of threads and all that stuff. And so that's when you see this, ultimately it's going to call this run or serve. If I'll talk about why this is different here in a second, but ultimately it's going to call this run. And this is coming from Lambda, which is ultimately coming from Tokyo because they've wrapped it. But you'll see in like even just like a simple
so it's even like thread management to some degree.
It's doing all that stuff. 100% of it. It's handling all the thread management stuff. It's handling, like if you think about something when you have asynchronous processes and thread state stuff, it's like, okay, well, who gets the next thread? When there's a thread available, who gets it? It's doing all that stuff for you.
And all the blocking and everything.
Exactly. Yep. So all that stuff is handled by it. For the most part with Tokyo, this is the only place you really kind of see it really in your main. It's marked there. And if you're running something more raw, you'll have a runner from Tokyo as opposed to this one, I think is ultimately just Tokyo. And if we looked at
I mean, they literally call it an asynchronous runtime for Rust. So.
Exactly. Yep. So
somebody low level was down in there and was like, we can't be doing this anymore.
Yeah, exactly. Like everyone's having to rewrite the same thing every time they want to do something. I think where again, I don't know the history behind all this stuff. My guess is there was a lot of kind of CLI stuff that was originally being written in Rust. And so that stuff really wasn't that important, right? The asynchronous stuff, multi-threading stuff, it just wasn't a big deal. I think as they started getting into like, let's actually run applications with this, now you start seeing it needing to do a lot more. Async is a particular one where, like traits, for example, you cannot have in the current version of Rust, you cannot have a trait with an async function on it, method on it.
Oh, wow.
You can do some weird stuff to make it happen. There is a package that allows you to do it, and they are working towards supporting it, but it's just not there today. So it ends up being really weird if you want to do that, and that's where it ran that whole dependency injection thing ended up being a royal pain. Because,
but if you remember when .NET Core came out, it didn't have that ability. That didn't come out until, I mean, I think it was like almost like the third or fourth major version.
I don't remember.
But
it's been so long.
It's not an unusual thing to not be there at this point.
So anyway, so that's Tokyo. Again, not something like you'll see this, but you don't really have to worry too much about it. So what I'm doing here, let's back up a little bit. A history of the way this specific code is done. So I was just telling TJ before this, I'd written a blog post last week that was around being able to take. In the blog post, I was taking some Node.js code and I was running it as a Lambda function or in an ECS container. And it was coming through an application load balancer in AWS. And effectively what it would do is if the load was significant enough, it would run an ECS. But as the load dropped off, it would say shut down ECS and only run it through Lambda. And then if the load starts back up again, kick up the ECS container again to ship that load. So same code, some deployment stuff, and I'll show you. I did the exact same thing here. So this API gateway is designed to be able to run both in Lambda and on ECS, and it actually is running in both. So what I do here is I'm actually grabbing these two values from the environment, and I do that because I'm going to show them like in my response. I'm like, hey, this one hit this one versus the other one. Again, the shared config thing, just like we had before, where I'm grabbing it. Actually, I think this is the new way you're supposed to do it instead of from environment. Load defaults, but it's the same thing.
Yep.
Arc. So Arc is a memory thing. And we'll talk a little bit more about memory, but at the end of the day, everything in Rust from a memory perspective is tracked really closely by the language. Like the moment you take a variable and assign it to something else, that variable can't even be used anymore. Only the new assignment one can.
Wow.
This concept of ownership and borrowing. And so it's really limiting. In Arc, what Arc is for is when you need to do something that's out here, right, where potentially this is going to be used by more than one thing. Arc stands for automatic reference counting. And so effectively, it's going to put this wrapper around it that's going to say, okay, I'm going to keep track of how often this thing's being used. And once something goes in and out of scope, I'm going to track it. And once all of them are out of scope, then I'll get rid of the memory, free that memory up.
Oh, that's pretty cool.
So
wait, I can't make a string a number and then a number a string?
Oh, you can do that. So that's actually kind of interesting. It's actually int x equal 1. What you can't do is I can't do x equal a. That will get mad. And it does pretty good telling you what was wrong, like expected an integer. But what I can do, that works.
Oh Lord.
But now that seems really like dangerous.
But they're different memory references.
They're different memory references. The moment you do that, this one's out of scope. And so you can't get at it. And I'd say that the example they gave for that, where it is sort of useful, is think about how many times you have something that brought into you as a string that all you want to do is convert it to
That's exactly where my mind was going. Was like,
and it's great for that, right? You like let X equal the string value that it came from, and now
or even as your stuff is going through, the entity layer, the DTO, and then out to the result, right?
Yep.
Like you can be consciously dropping or taking the initial variable out of scope and replacing it with the correct type of thing as it hits those layers, and that's pretty cool. Like I can see how it can be useful.
I can see its usefulness. I can also see how it's dangerous. But I will say the one thing about Rust is everywhere it's dangerous, like that, it's a compile time dangerous.
Oh, so I mean, it's dangerous for your health as a developer, but not
right.
Really
you're not going to do something. You're not going to do something wrong. That's not to say that you can't do things wrong in Rust. You can, but it's a lot more difficult to do things completely wrong and actually make it compile. It will give you compile errors, and you'll know at the time you try to compile it, it's not going to work, and it won't ever get to that point. So there isn't a risk of like accidentally getting out there in production and oh crap, So that part of it's okay.
It never happens in JavaScript.
Right. Never, ever. JavaScript, the land of freedom of do whatever you want with everything. Same with Python. All right. So here what I'm doing is I'm creating this shared state object. And ultimately, again, this is a router. So this is that Axum thing. This is, again, very similar to what you'd see in Express. But what I'm wanting to do is I want to pass some shared information into all those guys. And so they have this concept of state that I can pass in. And so I've just created this state object. It's just this guy up here. And that help kind of gets annoying sometimes. Again, I'm passing that shared config, and I'm passing a runner name here, which is just going to be like, if I'm in ECS, I'm going to put the host name. If I'm a Lambda function, I'm going to put the function name in there. And that way I can use that inside my code.
Oh, that's cool. That's actually really interesting.
Yeah.
So it's kind of like, oh man, I'm just thinking through that. Like, that's really cool that you can pass like a shared state. It's almost like, it's kind of like inheritance, but not.
Yeah, it's a lot like they actually have middleware here too, but it's similar to like middleware, but it's more like these are things that you're going to use the same across all of them, right? It's like it's not like it needs to travel through it every request. It's more like these are things that happen when the application starts, and here's some information. Do what you need to with it. It's kind of like just a nice little way to get. Sure,
I bet you AWS has something for like all the context and stuff.
Yeah, so the context stuff is actually built in. I
wonder if they just are automatically with stating it somehow.
I think when inside this run handler, it's doing that. This is AWS Lambda HTTP runner, so I think it's kind of handling that inside here.
Yeah, that's cool. No, I was just, you know what I'm talking about, like where you can like basically be getting the AWS account, what was the function are, and all that,
Yeah, you can get all that stuff. I don't remember exactly how you can do it here, but if we go back and look at the simple code, so this guy is getting a Lambda event, and this event, if we look at him, event dot, it has the event dot context, and that has all those things in it.
Yep.
So presumably there's a way to get that in this guy as well. But
no, cool.
This little block of code here is how we handle running in either ECS or Lambda, and this is the only code that knows about it. So I basically have an environment variable that I set to 1 if I want to run it in ECS, and if I do, it's just going to start up a new socket, create a TCP listener, and serve this code and run it.
Well, that's kind of cool because it also kind of does you can run it locally.
Right. Absolutely.
And so
that's how I tested it. Yep.
In all reality, it's like running. It's kind of like running what you're going to run in your Lambda, but local in a local fashion. So like that's pretty cool. Like I actually like that a lot because like there are a lot of times where we're lucky to have individual developer accounts, but like this would give you the ability to run it locally and do some of that debugging up front.
Absolutely does. Yeah, so it can be really nice for that. Otherwise, we're going to run it as Lambda. And then over here, it's just all the different functions. So I didn't create an object. It's just, again, this is a functional language, so it's kind of the way I did it. So if you looked in here, you'll see the route get /user get is calling the list users. Post is calling create user. Just, you can see those are all the different things that we're calling. And those are just these functions here. Again, not, the create user is just like it was in the little simple thing. I'm just calling save user. In this case, I'm going to say user was created. I added a get user here so we can get it. We'll call the user manager's get user ID. Now this is one where I said, hey, take that result, and if there's something there, then I want to return status OK and serialize that object to a response. Otherwise, I'm going to say if I got back none, which means it succeeded, but it didn't get an error, but there was nothing there, then I'm going to do a 404. Actually, in this case, I'm doing an error. I'm doing a 404 too. That actually, realistically, I should say, or I should do error as a separate thing and return like a 500 or something.
Okay, so that or is basically saying if it's okay none or error
or an error, then
return that.
Not bound.
And I don't know. There's the security thoughts that come to mind where I'm like, it's not too bad to not be leaking the error.
Exactly. Sometimes that's not a bad idea. As I would say, like if you were really to do this from a software perspective, whether or not you return a 404 or an error, you definitely would want to separate these out and log the difference, right? And be like, hey, that way you can do alarms and all that stuff, which I think that's kind of the key there from a security perspective. But other than that, you'll notice here I'm including the runner name here. So when I say user ID not found, didn't do it on user creator, should have. On this get, I'm not actually doing like a list right now. I'm just returning, hey, I am get user, and here's the runner name that I'm running under. So we can see what that looks like here in a minute. And then the health check, just returning.
Okay, and that's for the Fargate.
For ECS. Yep. So this guy's a little bit more complex from a deployment perspective, but ultimately he's in the CVPC. Yeah, exactly. Yeah, there's a bunch of stuff here. I'm not even going to get into that. Ultimately, I've got an ALB, I've got a VPC set up. But so this is going to create a cluster for ECS. But the cool thing is I want a Docker image, and where is it that I'm actually telling it? Don't remember where that's at. Oh, it's just the Docker file. So ultimately it's running the Docker file. This Docker file is at root. I ran into problems with where the Docker file was. So,
interesting.
I'm not real sure on that. This little bit here, this is this machine that I'm on here right now is a M1 Mac, and it has some issues, so I had to do this little bit in here. Most people don't need that. Ultimately, what it's doing is going to run a cargo build, and it's going to run it for this particular whatever this guy is. And stick that into this workspace, and then it's going to copy all this stuff over. And ultimately what I'm copying is the /app/API gateway. And that's what it's going to run. And so if you look at this folder structure, it's going to be taking release and API gateway.
Yep.
And that's just an executable. So it's just going to run that. Obviously, you can see I have this set to 1, because if I don't do that, then it's not going to work right. I don't know why I said 8080 there. I'm also not sure why that's working, because I'm not exposing 8080, so that's interesting. But I'm pretty sure this works, so I'm not really sure what's going on there. We'll ignore that for now. So we created a Docker image. The cool thing is just creating this in here. It's going to run the Docker file for you. It uploads the thing to your ECR and creates test definition, all that stuff. I put that run local in here too, so I'm not really sure why it's in both. There's basically 2 health checks that end up happening. There's one health check for the container itself.
Yep. And then
there's a health check from ELB. So I actually put, just because I was running into problems early on, I put a query string on here to tell me where this health check call was coming from, because I'm hitting the same endpoint. What I ended up running into, and you can see in my Docker file here, I had to run apt-get on curl because I didn't have curl.
Interesting.
And so I'm trying to run curl as my health check, and it's like, yeah, I don't have that, so it will just keep failing.
Do
Obviously.
they have I wonder if they have containers
with
that
it
that was like for Fargate and Rust.
Probably. I was
like
just
AWS one.
Probably. I don't even know that it would need Rust
or whatever the runtime is that they suggest. Or
it would just need to run. It just needs to be, it needs to be the same Linux platform level, ARM 64, whatever. That part of it needs to be the same. There probably is one that has curl built into it already. I just was going with.
Yeah, I was just curious.
Yeah, I'd be willing to bet there is for sure.
Maybe not.
Interesting. I mean, ultimately, this is a slim version, so it's a pretty lightweight version of Debian. But I don't know if it's,
yeah, you're probably using one of the stripped down ones.
It is, yeah. And which is great because again, Rust is so efficient. You don't need much extra stuff on there, but I needed curl to be able to run the health check. Container mapping, had to have, of course, security groups, ingress rules, all that stuff. And then the actual Fargate service, which is running that task. What ends up being interesting is the other handler that I wrote. Oops. And again, I pretty much copied this from my my code for doing this with Node.js and Express. This is handling an event that is basically an alarm off of CloudWatch. So you'll see in some of this code where I create an alarm that basically is tracking requests. And so this gets triggered whenever that happens. Not a lot here. Again, all I'm doing in this is just getting that shared config, passing to the function handler. And the function handler is grabbing all that stuff from it. It's looking to see if the new value is alarm and the old value is okay. And then I want to scale it down, I believe. And yeah, scaling that one down. And if it's the other way, I'm okay down to alarm. Then I'm going to scale up ECS, and I want ECS to take over. And so basically all I'm doing here is I'm switching the listener to be 100% on Lambda and 0% on ECS, and vice versa when it's the other way. One of the cool things here that's important to know is, ECS takes a little while to spin up, right? So if I have a container, what's cool is until this health check hits okay, even though it's at 100%, it'll fall back to Lambda.
Right, because it won't make the switch until the health check.
Yeah, it's basically like, hey, the health check's not good, so I'm going to still send load over to this guy until it's good. So I didn't have to deal, like I was starting to go down that path, and I'm like, oh, I don't need to. So that's actually really cool. It ends up making this pretty easy. The one thing that I don't have in here right now is I'm just like setting the count from 1 to 0. Obviously, you'd want some more scaling code in here to have it, auto scale up and down. But you could certainly have that complexity. So what does this all look like? So I have these different Rust codes. Rust code, the Rust API gateway here. This is the actual code that's going to get hit. I'm going to go over to EC2. This is actually the easiest place to see what it's currently doing. And I already deployed this because this takes a little while to deploy. If you look at the load balancer, it has this rule, and it's basically saying everything, right? This is the default rule.
Yep,
currently it's going 100% to Lambda. So, oops, did not mean to do that. I'm going to bring up Postman here. And I'm going to do get user here. This is one that shows where it's coming from. And you can see it's coming from the Lambda function.
Yep.
Now, what you'll see if you go look behind the scenes here pretty soon, let's go just look at CloudWatch real quick. Let's go alarms. Open this alarm. Right now, this guy's in alarm state. Basically, there's no traffic. He'll very soon, he'll spin up and be like, oh, hey, I've got traffic. What that will do is that will trigger that function we're just looking at. That function will ultimately switch it over, and I'll be able to see the traffic is now going to ECS. So kind of cool.
Very cool.
Nice way to, it's not quite like I go completely serverless versus not, because it does have an ALB in front of it, which means that I'm paying for, at a minimum, I'm paying for IP addresses for the ALB. Yep. And I think those cost like, I don't know, like $15 a month or something like that. Maybe.
And the VPC.
The VPC doesn't cost too much because I don't have a NAT gateway, but I did have to put in, or those to be able to call into like ECR and
the service endpoints.
Yeah, the service endpoints in there. So those do cost a little bit based on traffic and stuff. So there is some overhead to those. So this isn't like going to run for basically free when it's offline, but it does reduce your costs. You're not going to be paying for ECS all the time. You're only going to be paying for the actual like ALB part of it. So kind of cool.
I wonder if you could do with the new CloudFront Origins, like if you could be writing something into the key value store, and then that tells it to go to the Lambda or the
probably ECS. Almost certainly. I think even if you did that, the problem is in order to access anything in the ECS container, you have to expose it someplace.
Right.
And unless you only want a single container running, which you could do and just have that one floating out there, you've got to have an ALB in front of it, or they've got their service meshy kind of thing. I'm not sure if that's even still supported.
Yeah, it's been a while since I worked with Fargate.
Yeah.
So I don't remember all the network stuff.
I had to like really think through all this. I was actually, one of my original ideas was, okay, let's put this behind the API gateway, have it call a step function, and have that step function call the load balancer, and if that gets back like 503, then have it go to the Lambda function instead. And like conceptually that was kind of cool, but at the end of the day, it was a lot of extra work for something when I had to have the load balancer there anyways, and I could just call Lambda function. So this ended up being a lot easier than that. But
yeah,
let's see if this goes. There he goes. So now he switched. I bet that we're probably already up. Let's see if. Oh, so this is the one thing I've seen every once in a while. It's actually sending load over to it, which it really shouldn't. There it goes.
Oh, most likely it's probably one of the health checks is probably saying it's good.
Yeah, even though it wasn't
probably
ready.
Prioritizing the because there's 2 health checks, right?
Yep.
It's probably prioritizing the wrong health check.
So it could be, and this is where like if you're really running into that, like you can add some more complexity. As a matter of fact, I originally started down the path of adding some complexity to that handler and be like, okay, well, switch it over, still leave it on Lambda, and then have something watching the ALB to see whether or not the ALB is ready. Once it's ready, now switch it over to that, to see whether or not the health of the ALB is not the ALB, but the actual service, because you can monitor the service status.
Yeah.
And so you could do that to kind of avoid that. But ultimately, now you can see it's pointing at the other one. So that's that. What other things are worth talking about with Rust? So we talked really briefly about memory. Rust memory is where it gets complicated. Just to kind of show you like how weird it is. I'm going to the upper line. All right, so that works fine, right? If I now do let y equal x, Why is it not letting me do? Oh, because I let my autocomplete finish for me. You'll notice now it doesn't let me do that.
Oh, wow.
And it's because the moment I assign that to Y, now X is no longer, it doesn't have ownership of it anymore. You let Y borrow it, and so now it's saying, okay, it a little tells you borrow of mood value X. So you tried to use it after somebody else borrowed it. And so you
Interesting.
can't. Yeah. And that really is like that concept is the essence of Rust memory management. And it's like you've done like C++ or any of those. Have you done any of those lower level programming languages? So you had to deal with pointers and all that stuff, right? Effectively, you don't have to deal with pointers. They manage that for you, but they make it to where you can't access memory that you don't own by virtue of managing this stuff for you. They basically take away and say you can't get at it because it's not in your scope, and so it does some interesting things.
That's why you see clone everywhere.
Yeah, it is. It is. As a matter of, like that's one of the ways you get around this, right? But of course, clone is expensive, right?
Right.
Potentially, it's one of those where you have to look at what the potential impact of that is, right? Because copying a string, if the string is small, no big deal, right? But copying a big object,
what if you do an ampersand X?
Yeah, ampersand is just by
reference.
Yeah.
Could you let Y be the reference to X? Like, is that valid? I don't know.
It is valid.
I'm asking weird questions now.
It is valid, and it works because
Y has only got a reference to
Correct.
X, and you haven't actually borrowed
Correct.
the memory space.
Correct. Yep. So it's sort of where the nuances come in. And when you use function calls, right? So when you use a function call, most often you want to do it by ref, because if you don't, you've borrowed it and nobody can have it anymore. Because when that function goes out of scope, it's completely out of scope. But when you pass it by ref, now
it'll garbage collect it as soon as it goes out of scope.
Exactly. It's garbage collection without garbage collection, right? Because it doesn't have the overhead of garbage collection happening. It's just pure memory management.
Yeah, dereferenced.
Yeah. Exactly. Dereferences is literally what it is. The concept of mod. So this is interesting. So I can't do X equal. That fails because I can only assign it once. If I want to be able to, it's more like a const.
Oh, weird.
In like .NET, but I can do this. I can make it, now it's modifiable. Why is that not liking that?
Oh, because you got to get rid of the let?
Oh, not mod, mute.
Oh, mute, yeah.
So this is where, again, like doing.
And now you can?
Yeah, now you can. Now you're saying it's immutable. It's something I can change. And so I can.
We're always pleasing the JavaScript crowd.
Yeah. And it becomes like, again, like this is where you run into all your problems with Rust. It's not that the language itself is particularly different in a lot of ways. It's that everything it does is all about memory management. And so you run into weird things. I'll show you an example of one of the weirder things. And I don't even understand it well enough to fully explain what's going on here. They have generics that work a lot like we'd expect generics to do. But this is a special kind of generic thing. And this is a scoping modifier. And ultimately what it's trying to say is this client, when you create this struct user database DynamoDB, you're going to pass a client into it, and that client is going to go out of scope at the same time the struct does, or at A, right? You could have multiples. Like, so let's say I had, I don't know, foo. Well, actually, let me just do another one of these. Just for whatever reason, you've got two different clients. But we're going to make this one B. Wait, make sure that's right. Yeah. Oops. I didn't do that right. All right. So now I've got two different scopes. When the A scope goes out, the first client goes out of scope. When the B scope goes out, the foo client goes out of scope, and it's this weird.
And how does A go out of scope? I guess how does it go out of scope different than A and B?
It's all about like functions that end up using it in different ways. Again, this is one of those where like I don't have my head wrapped around it well enough to fully like explain it, and even fully understand when I need it. But it's this whole weird. Again, it just has to do with the whole memory borrowing thing and things coming in and out of scope and having it. Really, what it came down to is because there are multiple things that are in scope, it doesn't know which one to tie it to, and so it can't guess. It can't know. It could, at best, it could guess, and so it's a way of explicitly telling it these are the things that are related to each other. When one goes out of scope, the other one should too.
Well, it's almost like it's like it's almost like being able to have multiple type definitions in there.
Yeah,
because you're like just have T, right? Like maybe you have a couple T's, but you don't generally see more than one T, right?
Yeah, I mean,
maybe that's why
it's more than that, because this isn't even a generic. If you look at it, there's nothing about this that's really generic.
Oh, really?
Yeah, like this isn't a generic function. It's only generic because I needed to do the scoping and I needed it, and it was one of those where it was telling me it needed it.
Yeah,
I don't know that I really understood why I needed it. You can read about it. They do talk about it, and they're again, like, this is relatively fresh to me, so I'm still trying to wrap my head around it a little bit. But it does become kind of weird, and some of their memory stuff becomes weird. You'll see like the way this works is a little bit odd, right? So I've created a struct which is just has this client, but now I have an implementation of it. The implementation has functions in it. Methods. And so like when I create this struct object, now I can call new on it or save user, or this is a static function, but this is the only difference between effectively a static function and a non-static function is whether or not it has self passed in as the first parameter. So this is more like if I want to create a new one, I could create like default is another one that's pretty common, and you'll create one with a default client or whatever. Obviously that doesn't work, but you can do that. And so if you wanted to, their model of newing something up is a little weird. We looked at it, but we didn't really pay that much attention to it. It's : instead of dot.
Oh, yep.
And when you do that, you'll see all the things that are at the top level there. But if I have self, then I get a reference to self, which in this case includes the client, and I can do stuff with that. So that part of it ends up being very similar to what you'd be used to in a lot of languages if you're doing, classes. Mm-hmm. This is effectively kind of like a class of this object, but it's weird that it separates them.
Yeah.
Like why isn't this just one thing? I don't know. Just the way they did it. There's some nuances to it that are interesting that way.
That's so weird.
Yeah.
I'm trying to look through the library or the Rust by example, and
yep.
It's definitely a different way of thinking about it.
Yep. It's so as we're getting kind of running out of time here, I was thinking through a lot of when would I use this, when would I not? I think if you have some things that really do have this critical performance element to it, I think it makes a lot of sense. If you have a real need or even desire to really reduce your environmental footprint, it's great for that. I think the thing that you can lose is there is enough complexity here to where, I can figure this out and I can get good at this. Can everybody get good at this? It's going to be a lot more challenging for a younger developer to really wrap their heads around some of these concepts, especially because what they're learning largely are things like Java, like JavaScript, Python, where all the memory is managed for them. and they're not having to think about things that you have to think about here. And so I think there's a lot of complexity that comes with that. Obviously, the one thing that I'm always going to be a big proponent of is keeping your mental load as low as possible. And so if you are doing full stack, you're going to have a hard time convincing me that it makes sense to use anything but TypeScript, JavaScript in the backend.
Yep. No, I totally agree. And then I think it's like you said, it's, don't use it as the hammer,
right?
And try and do it on everything, right?
Yep.
Like, there's some specific cases I can think of, but even in some of those specific cases, there's caching mechanisms that can relieve some of that, like cold start stuff. And I mean, Lambda's come a long way with the snap starts.
Correct.
And all the
and even that, I mean, even just the example that we just did here with running Rust or running in ECS and Lambda, you can do that with Node as well. Yep. That was the first example I did. So like those options exist too, and so there are other ways to get your performance taken care of for you. You're not going to beat Rust overall in performance without going down to like C++, C, and it's going to take a lot more resources, right? These run on like really, like you can run these things on like 128 meg, like ridiculously small, right? You're not going to be able to beat that. But the overhead, if you're looking at it purely from a cost perspective, there's a lot of overhead to having people learn and understand and manage a Rust project. So if you got people that know it, great. If you're looking at a long-term 5-year plan and you got enough, resources to handle it, great. I just don't know that for me, I would see this as the right solution in most places. I think it's the right solution in a lot of places. I don't think it's the right solution in most.
Yeah, I mean, from an application, I mean, I'm going to steal a screen from you real quick. But even from, if we'd go look at like, so if you don't know, there is a project that is running basically
daily
10 cold starts every day.
Yep.
Right. And you can check against whatever architecture, the size. And so like I usually look at zip arm 512 because like kind of almost everybody does that, right?
Yep.
Like it's almost, if I were to go into a project right now at a company that I have no idea about, I would still bet that it would be zip arm and 512.
Yep.
And like you can't take away from Rust. Like obviously 11 milliseconds is
fantastic,
ridiculously fast.
Yeah.
But even when you do get down into the nodes, I mean 139, is a human really going to notice that? Like in all reality, in the worst case scenario, like probably not.
Most time no.
And keep in mind that's the cold start.
Right.
So like that's the worst case scenario. Nothing was warm.
Right. That's really interesting because if you look on this, right, they show cold starts, but they also show warm, right? So the 3.32 milliseconds on node 22 warm start. Well, how does that compare to Rust? Well, Rust is 1.82. Okay, so it's half-ish.
Yeah, but at that
level is that half? Right. Like, now, here's where you'll see the difference. Change that to 128 meg.
Well, yeah. Now we're talking.
Yeah. Now is where you start seeing the difference, right? Because now you're at like, notice Rust pretty much didn't change. It's Rust provision 82 is 158, and now you're running at 9, almost 10 milliseconds.
Poor Java 21.
Yeah, it gets it doesn't. It's like
it's just a permanent garbage collection.
Yeah, it's like I'm actually better off if you just cold start me every time, please. If you're going to run with that little memory.
That's hilarious.
Yeah. So yeah, absolutely. And image is actually interesting. Image was the way a lot of people were going. I think image may become more popular because what was happening was a init time on a Lambda function was free except for images. They just changed the pricing model to where a init time is you're being paid for it all the time, regardless of zip or image. I think that will cause a lot of people to switch over to image.
Yeah.
But it's not great for Rust. It's slower on Rust by quite a bit.
What about the bigger sizes?
Yeah, I mean, what it comes down to is it has a little more processing power and probably a little bit more bandwidth to pull it in to actually get that
pretty
image
significant at the larger.
Oh yeah,
256.
So,
but yeah, I mean, but 141. I just
have
a hard time believing that a lot of these
I don't think that's where your problem is. I think
a lot of the web applications and stuff that there's obviously the people that those milliseconds matter, and
Absolutely.
not going to take away from that. And
I think the thing to keep in mind though is that how often are you chaining things or like call this and then call this and call this. That's where it adds up, right? Because if you have 100 milliseconds and you call 5 things that have to be done serially, now you're at a half second. Whereas if you could have done that in Rust, you're at still less than 100 milliseconds, and so you're still at that not noticeable point. But you're right. It matters, but I don't think it matters as much as a lot of people think it does.
Yeah. No, but there's definitely it always comes back to the same thing. Use the right tool for the right job. And be flexible and keep learning. It's why we do this.
Yep. Absolutely. Cool. Well, I think that'll end it for tonight. We'll try to be back in 2 weeks. Figure out what we're going to talk about then. We'll get something figured out between now and then. But until then, thanks everybody. Later.